Assalamualaikum and hi to all. According to the report from NASA, the tin whiskers growth phenomenon has caused billions of dollar losses in satellites, missiles, radars and other equipments. Briefly, tin whiskers is not an imaginative. Tin whiskers phenomenon are real. They can bridge fairly large distances between electrical device links and can short-circuit the conductors. Why I do tell you these things? Because the main goal for this invention is to mitigate tin whiskers growth by our novelty product, which is phase stabilized lead-free solder for aerospace electronic interconnect applications. First of all, I would like to introduce our research team. Me, Aini Norliana Hashim, a group leader in this invention product. My expertise in tin whiskers, lead-free solder and metallurgy engineering. Second is Associate Professor IR Dr. Muhammad Arif Anwar Muhammad Saleh, who is expert in electronic packaging materials, lead-free solder alloys, intermetallic and manufacturing engineering. The third one is Nur Zaimah Muhammad Mokhtar, who is specialist in tin whiskers, lead-free solder alloys and surface engineering. The last one is Dr. Muhammad Izrul Izwan Ramli, who is specialist in intermetallic, lead-free solder alloys and materials engineering. Due to the transition of the electronics industry to lead-free solder, the issue of tin whiskers has become one of the most imperative issues that needs to be resolved as soon as possible. Moreover, the miniaturization in microelectronics package causes tin whiskers is a severe threat to the reliability of microelectronic device. NASA identified several total satellite failures due to tin whisker growth including Galaxy 7 in 2000, Solidaridad 1 in 2000 and Galaxy 3R in 2006, all caused by tin whisker growth in pure tin plated relays. Many tin whisker faults were identified in shutter electronic and corrected. An assessment of the tin whiskers growth is difficult because of the slow and unpredictable nature of the tin whiskers formation. It is very hard to estimate the period for the growth of whiskers, which can vary from hours to years and can often result in unreliable tin whiskers growth. Tin whiskers growth can extend from thread to thread, pad to pad between any leads and other metal areas. The tiny whiskers are highly conductive and can result in catastrophic or intermittent circuit failure. Amazingly, no PCB surface treatment, post-coating or solder masking will prevent it. Therefore, the development of new lead-free solder has become an important issue, and the existing researchers mainly focus on developing lead-free solders for soldering and packaging materials. In view of the lead-free solders, the risk of tin whiskers growth in solder joint should attach great importance. In order to overcome the tin whiskers problem, this invention endorsed the influence of nickel addition to the copper-nickel solder alloy to suppress tin whiskers growth and enhancing its wettability and stabilize of hexagonal structure of copper 165 IMC in lead-free solder alloys. The driving force for tin whiskers formation is generally accepted as the compressive stress generated by the diffusion of copper atom into tin film accomplished with the formation of thin copper intermetallic compound IMC layer at room temperature. As the IMC particle grow, their volume expansion create a stress region that extend into the thin layer. Nickel addition in thin copper solder alloy have significant implication on the thin whiskers formation and growth behavior. Nickel addition can create stabilization of the hexagonal high temperature phase of copper 65 and assist to enhance stress relaxation in the layer through the formation of fine needle-like copper nickel 65 at the solder substrate interface. The morphology of copper nickel 165 IMC interfacial layer was relatively thinner and more refined, with a continuous fine scallop-shaped IMC interfacial layer effectively suppress the thickness of IMC interfacial layer and come up with a greater incubation period for the formation and growth of thin whiskers. This invention, thin copper nickel, has an obvious suppression effect by diminish the propensity for formation and growth of thin whiskers. As shown in this figure, thin whiskers growth were found greater on the thin copper solder with the growth of filament and band-shaped thin whiskers, whereas the hillock shape was observed on the surface of thin copper nickel solder joint. In terms of properties of lead-free solder, thin copper nickel show better mechanical properties such in wettability and resistivity. Even when we compare the price, thin copper nickel is a low-cost solder among other commercial solder. Thin copper nickel is recommended to replace existing thin copper and thin copper solder alloy in soldering application, especially for aerospace electronics interconnect application, as the solder has a big potential in mitigating viscous kinetic growth of lead-free solder joint. This invention also contribute an impact on society, economy and nation. Here, the list of our publications relating to our invention. This product invention have done industrial collaboration between Nihon Superior Japan, the Tin Industry Board Malaysia, and Centre of Excellence Geopolymer and Green Technology, School of Materials Engineering, UNIMEP. Here is our invention pattern. First is patent filing from University Malaysia Perlis, and the second one is US patent under Nihon Superior Japan and research collaboration with us. Our team research also active in collaboration with Queensland University, Australia, Synchrotron Light Research Institute, Thailand and local university. And lastly, our invention achievement from news release. That's all. Thank you for your attention. It is hoped that our invention is the real solution developed to eliminate or mitigate the thin whiskers problems of green reliability lead-free electronic assemblies.